With this lesson, we're going to work on multiplying decimals. And before we launch into it, I want to emphasize that this video is going to use the box method for multiplication. We will quickly review like the standard algorithm that you may have already been taught. This is going to show you another way of multiplying that you may not have seen before, that a lot of students, once they get the hang of it, think is actually easier. We'll use that method to accomplish our objectives of, now we're going to see the exact result when multiplying decimals, and with that we can determine the area of a rectangle, and we'll also be able to calculate the cost when we purchase fruit. Now, some basic things that you need to know. Of course, you have to be able to count. If you're going to multiply decimals, counting matters. You also need to know how to multiply your single-digit facts. You know, for instance, 8 times 7 is 56. You just have to have those memorized. Additionally, you have to be able to multiply whole numbers using whatever algorithm you choose, whether it's the standard method, whether it's the box method. You need to be able to multiply by hand anyway. Okay, so when we're creating these pieces, to create a visual model for this project, for this product, 1.5 multiplied by 2.5, it can actually be represented with rectangles. In particular, when we're looking at this, 1.5 would tell us and 2.5 would tell us that when we're multiplying these pieces, 1 by 1 would give us just this one square. And so we'd be able to bring up another one and see then that we wind up being able to get these two whole squares and then a bunch of other fractional pieces. Well, when we're looking at these fractional pieces, this little half piece, of course, this is giving us half a square, and up here we have half a square for left and right. And so we wanted to be able to take all of these tiny little chunks put together, plus this last little piece, which would be a quarter of a square, and we can add up all the chunks and eventually get our answer: 1, 2, 3, 3.5, and a quarter. We get 3.75. Creating a visual model like this isn't the most critical skill that we're developing, but you should know that multiplication can be very easily represented just by using boxes, using squares and pieces that are like part of them. Now, when you choose to multiply, you'll notice right here, there is absolutely no need to line up the decimals. With our previous video, when we were adding and subtracting, we saw that lining up the decimals when you add and subtract is really, really important. It is completely irrelevant. You do not need to do that at all when you're multiplying. In fact, when you multiply, you can basically just ignore the decimals entirely. We can treat this just as the number 215 multiplied by 32, and just say forget decimals. Ignore them until the very end. We'll come back to it. Well, multiply 215 times 32 any way you choose. If you choose to use the standard method, we can take 5 times 2 to get 10. 2 times 1 is 2, plus 1 gives us 3. 2 times 2 is 4. Use our automatic 0. 5 times 3 is 15. 1 times 3 equals 3, plus 1 gives us 4. 3 times 2 is 6. And you already know this standard algorithm. We can just add them up: 0, 8, 8, 6. And then we see that 215 times 32 equals 6,880. Completely ignoring the decimals. Well, we can come back to this then and say, put the decimals in. In order to figure out where the decimal goes in our answer at the bottom, it's just based on counting. To the right of our decimal, we're now going to count up the number of digits. 1, 2, and 3. We have 3 numbers that are appearing after the decimal, which means that from the end we have to come in 1, 2, 3 places, our decimal should be located there. This is nothing more than 6.88. As long as you know how to do regular multiplication, you'll be able to multiply decimals because it's nothing more than regular multiplication mixed with counting. So let's look at this next one. 1.2 times 2.4 times 1.6. Well, we're going to start right here. We know that we can do these in stages. 1.2 times 2.4, which I'm going to take as just 12 times 24. Just ignore the decimals and do your multiplication. 8, 4, automatic 0. 2 times 2 gives me 4. 2 times 1 gives me 2. And when we add these up, 12 times 24 equals 288. Where would the decimal go in that 288? Well, 1.2, 2.4. When we're counting, we would see 1 and 2 digits after the decimal. So it needs to come in 1 and 2 places from the end. 1.2 times 2.8 gives us, 1.2 times 2.4 gives us 2.88. And so now that we've finished the first stage of this chain multiplication, we've got the next one, 288 times 1.6. Now, if you're a person who prefers the box method of multiplication, this is the one that I'm going to do now. 288 times 16. Okay, so 1 times 8, 1 times 8, 1 times 2, 6 times 8, 6 times 8, 6 times 2, multiplying each row and column, adding up the diagonals, 8, 8 plus 4 plus 8, that's 12 plus 8 gives us 20, so 0, carry over 2, 2 plus 8 is 10, plus 4 is 14, plus 2 is 16, so 6, carry over the 1, 1 plus 2 plus 1 gives us 4, and so we would observe then 288 multiplied by 16 gives us 4,608. Just like before, we need to determine where the decimal goes, because we had 2.88, 1.6, and so we would see 1, 2, 3 positions after the decimal, so we come in 3 positions, and there's our final answer, 4.608, 4 and 608 thousandths, and we're done. What about an exponent? Well, just remember the exponent tells us how many of them there are. 1, 2, 3. And so we have this chain, 2.4 times 2.4 times 2.4. Okay, so starting off, 24 times 24, 16, 9, automatic 0, 8 and 4, let's add up to 576. 576 times the third, because we did the first two to get 576, now we're using the third, so 4 times 6 gives us 24, 4 times 7 is 28, 28 plus 2 gives us 30, 4 times 5 is 20, plus 3 gives us 23, 0, 2 times 6 gives us 12, 2 times 7 is 14, 1 is 15, 2 times 5 is 10, 10 plus 1 is 11, 4, 5, 4, 3. And of course, I know that I rushed through the multiplying fairly quickly because, again, it's a skill that we expect you to already have down. you should know how to multiply. And so the last piece we need to figure out is, we've got this answer of 3454. Where does the decimal go? And I'm looking at this, and I realize now that I missed a number where I didn't write it down. The 2 times 6 stage, which would have given me 12. I forgot to write down the 2. It should have been the 2, and then 5, 1, 1. I forgot to write down that 2 when I was doing it, so they're not going to add up to 3454. Fixing that would be 4. Come on. 4, 2, 8, 3, 1. Okay, that's better. And so when we look at that, we've got 1, 2, 3 digits after the decimal. So we'll come in 1, 2, 3 places, and there's our solution. There's our answer. 13.824. What about area? Area of a rectangle is straightforward. It's just multiplying. In order to get the area, all we're doing is taking 4.1, multiplying it by 2.4. So 2 times 1, 2 times 4, 4 times 1, 4 times 4. Adding our diagonals. And then because we've got 2 digits after the decimal, we come in 2 places, we're done. 9.84 square feet. Lastly, say you're going shopping. I'm going to go buy some pears. Pears cost $1.89 per pound. How much would it cost to buy 3.5 pounds? Again, this is a piece where you need to multiply, so we would simply take $1.89 multiplied by 3.5 pounds, run through a multiplication algorithm, just ignore the decimals, so 5 times 9 gives us 45, 5 times 8 is 40, plus 4 equals 44, 5 times 1 plus 4 gives 9. Now we'll use the 0. 3 times 9 is 27. 3 times 8 is 24. 24 plus 2 gives us 26. 3 times 1 plus 2 is 5. And so when we add these, where would the decimal go? 1, 2, 3 places after the decimal, so 1, 2, 3 places in, we wind up with a price of $6.61.5. Which, of course, at the grocery store doesn't make any sense, right? You don't go to 3 digits in dollars, since money is always going to the rounded to the nearest cent. This is a problem that makes sense that we have to round this answer. And because our 5 tells us to round up, at the grocery store, you're going to get charged $6.62 to buy your 3.5 pounds of pears.